Good to see you. Good morning, everybody. It's so hard to hear. Good morning. So many familiar faces out there in the audience. So I've been pleased to be here as part of OCP since the beginning in the foundation, and it's really changed a lot over the years. But it's good to see so many familiar faces. It's like a family reunion, just much bigger and a lot more technical. So what I wanted to talk a little bit about today is how things are evolving. We're hearing from the community great feedback. Things are moving forward. And in the past 8 years, thanks to a lot of contributions from all of you and working together, the amount of hardware that's been deployed is now over $2 billion in the community. And we look at deployment because that really, at the end of the day, states, are we solving a problem? Are users adopting? Are we helping the community to take advantage of hardware that's more efficient, more capable, and driving ease of use? But what it really got me thinking about was, where are we going? What is it going to really take to get to the next $10 billion in OCP hardware deployment? What are the problems that we have to solve? And it really boils down to what we're hearing in 3 areas. And this is really what the board's been hearing through surveys and through other kind of customer feedback. Number 1 is we're moving to a world of workload optimization. And that's adding a level of complexity that we need to address as a community. The second thing is that systems continue to be hard to manage. That if you're a very experienced, large-scale operator, you have so many resources to go deal with your own issues, but how do we make sure that the community that may not have the same sorts of resources can adopt OCP hardware? And then the third thing that we need to address is, how do we provide integrated solutions? How do we make sure that these are repeatable, they're easier to deploy? So I'm going to walk through these 3 different areas and talk about what we as Intel are doing in the community, how we want to go address those problems. And I want to start with workload optimization. The first thing that we are looking at is that analytics as a whole continues to be a huge workload for the future of the data center. And so what we're making sure we do is drive platforms that have enhancements for that type of workload optimization. In one sense, we're taking and working with Microsoft on their Mount Olympus platform and upgrading it with the most recent generation of our Cascade Lake processors. This platform, by the way, will also take advantage of new persistent memory technology, and I'll talk about that in a little bit. But it also adds accelerating features for things like what we call DL Boost. And the DL Boost is actually going to provide up to a 10x improvement in AI inference performance on that platform. We'll be launching this relatively soon. We also are seeing the need for scalable platforms, and this is relatively new to the OCP community. We know that 1-socket and 2-socket motherboards and system designs have really been the bread and butter, the mainstay of this community, but we see workloads that require greater scale. So with the Cooper Lake platform and what we're going to be working on with the communities, we want to be able to deploy reference designs that show scalable systems. They can be 2-socket, or they can be ganged together to be 4-socket or 8-socket, depending upon the configuration. And the goal is to be able to have a large memory footprint as a result, and a lot of compute to be able to address those requirements. We also, for the first time, are seeing a need for what we call a cloud-optimized platform that's 4-socket. And so this is new in the industry, and I think I actually have a chassis over here I'm going to attempt to showcase to you folks, trying very carefully not to drop it on my foot. But this reference platform is really around the need for greater VM density. And when you look at cloud scale applications, the desire to drive more cores, and this will deliver up to 112 cores with 48 DIMMs. And this also will support the Apache Pass 3D Crosspoint Intel Optane persistent memory. When you put that into the system, you can get up to 12 terabytes of persistent memory in the system, combined with 112 cores. Again, ideal for highly scalable cloud types of applications. And this will be available again in the second half of this year. I should also just do a quick shout out and thank you. That design was contributed by our partners at Inspur. Huge thanks to the partnership and, again, working together to bring these designs to the community. We also want to make sure that we're driving new optimization around workloads for AI acceleration. And Kushagra mentioned this a little bit earlier, that we want to make sure as we move to a world of AI, the complications, we need to make sure we lower that barrier. And what we wanted to do is work on the standardization of form factors. We at Intel are planning to come out with new neural network processors this year. What I have here in my hand is the deep learning training accelerator. This is a neural network platform that's got high bandwidth memory on it. It's got high-speed chip interconnects, both on and off of the package, allowing you to be able to have a very scalable deep learning training platform. And again, it's important that we work together on the standardization of these form factors so that they fit into the open compute infrastructure. And we also have an accelerator for inference as well that'll be coming out, but because it's lower power, we're able to take advantage of the M.2 form factor to bring that into the market. Again, hardware is just not enough. You have to make sure that you have a complete solution. And in the interest of providing complete solutions, we're very active in the Glow community. Particularly the Intel contributions are focused very much on PyTorch and Caffe2 platform optimizations. It's great to have accelerators. It's great to have a platform, but we need to make sure that we have a way to effectively connect them to the platform. And that's why earlier this week we saw the need for introducing a new standard, a new open interface to the industry that we called Compute Express Link. And while Intel introduced the initial specification, we worked with a broad community to say this is something that really ought to be owned by the community. That's how you create a standard. That's how you work together. The Compute Express Link is based off of PCI Gen 5 technology, delivering 32 gigatransfers per second. And it's a high bandwidth, high speed, low latency interconnect. It creates a coherent memory space across the CPU and all of the devices that have memory attached to that bus, driving greater efficiency. And we look forward to working with the community to see what kinds of devices we can attach to the interface. We expect to deliver platforms from Intel as early as 2021 that are taking advantage of this specification. And in the open compute community, we need to start spawning working groups to work on the designs and how to go take advantage of standards around this interface. We also want to make sure that we're continuing to drive forward on network interfaces as well. And as you look toward higher speeds to keep up with the bandwidth needs of these high-performance platforms, we need to drive better improvements. And that's where the OCP NIC 3.0 adapters come in. And that's what I have here in my hand. There's a session later on today to go talk to it, and you can hear about what the specification is, what some of the improvements are. But again, the goal is to have a standards-based interface that's really ready for the next generation of network interface cards. Not just higher performance, higher bandwidth, but also offload. Again, back to workload optimization, not everything is going to be done on the core compute, and we need to make sure that we have compute where it's needed in an offload type of case. So we plan to have a full range of products from Intel that are compliant with this spec, up to 100 gig, available in the second half of this year. Continuing to think about bandwidth and connection in the data center, silicon photonics has been obviously a key to large hyperscale data centers. And we're moving from 100 gig CWDM4 technology to 400 gig CWDM8 technology this year. So we'll continue to work with the community to deliver modules to drive standards and make sure that silicon photonics across the data center is as deployable as it can be. But we have to address the next level problem, and that's really where optical integration comes in. To go make 25T switches a reality, we want to be able to drive the next level of integration to be able to integrate the optical network interfaces with the switch ASIC into a single platform. That's going to reduce the power at a switch level substantially by as much as 20%. And so our goal is to make sure that we're driving standards around the electrical interfaces, the die-to-die, and the die-to-optical interconnects to help make this a reality through the community. We also need to change things in the memory hierarchy as well. When we think about the next generation of optimization of workloads, there's a whole range of solutions that can take advantage of Amdahl's law in different ways to manage the memory and the storage hierarchy across the board. As I mentioned earlier, we are very close to launching in a broad way our Intel Optane persistent memory. And this is really a game changer. It's got two different types of modes to it. One mode is what we call memory mode, where essentially the application just sees one memory image where the persistent memory is really what it sees, and the DRAM acts as a cache. The other mode is what we call persistent mode, where the application is aware of both the DRAM and the persistent memory and can optimize and manage across both. But the level of capacity, the efficiency, and the scale that we're going to be able to drive in terms of a memory footprint in these platforms that are designed for analytics is going to be dramatically increased with this technology. We also want to make sure that we're driving standards for the storage side. And I won't recap because there's a whole range of different storage technologies supporting different form factors that are part of the OCP community already and Intel-based designs. But what's really new is we're working to make sure that there are other form factors for very high density storage. And for looking at things that are JBOF types of applications, opening up the ruler form factor to take advantage of Intel 3D NAND and the capacity in it is one of the ways that we're looking to add new innovation into the community. So we just talked about all these different ways that we're working together to optimize for workloads, adding accelerators, a new compute express link, new platforms that are scalable, all of these available to the community. But it's still not enough. We have to drive standards around open management. We have to provide more integrated solutions. And I want to talk about some of the things that we do and what we'd like to work with you on to go advance those. One of the first things is really how we've been continuing to focus in on rack scale design and technology. And this has been a consistent theme that I've talked to many of you in the community about, which is we need to go drive to a disaggregated type of platform. This will allow much more interoperability. It'll allow scalability for different types of workload optimization. And so the goal of this type of platform is how can we have pools of compute, pools of accelerators, pools of storage that essentially can be aggregated or developed into a single system that then can be provisioned based on the workload requirements. And we've been hard at work in the community demonstrating some of the value and demonstrating some of the capability. And you can see a couple of the pictures here we have that have demonstrated a pooled NVMe over Fabric in a very high performance way, as well as FPGA pooling so that FPGAs can be attached to workloads based on their requirements. We've been working very broadly in the community for some time, and there are a lot of good efforts underway. If you look at firmware, OCP has an open firmware project, and we are an active member and a contributor there. In BMC firmware, the Linux Foundation has been driving open BMC. And what we found our role to be is that we know that you in the OCP community care about Redfish APIs, you care about OCP profiles, and we've been working to make sure that we span both those organizations to get those requirements into open BMC. But we think that there's still more that needs to be done, and that's why today I'm very pleased to announce that we are opening the RSD 2.3 rack management module contribution. And this is both a spec that we're contributing to the community, as well as reference code to allow for a northbound interface to, from the rack to help go drive the next generation of management so that applications such as NVMe over Fabric, such as pooling of FPGAs or other accelerators can be done more efficiently in a comprehensive management structure. So we look forward to you joining our projects here and to be able to contribute on top of that to drive the rack management firmware approach. So I want to announce one other thing today. We're really excited about the importance of security. Security is crucial, and I want to invite up on stage Anil Rao, who is Vice President in the Data Center group, and also Kushagra Vaid, who was just up here on stage a little bit ago from Microsoft, to talk about what we are doing and how we want to extend what's been built on from Cerberus to extend the platform root of trust. Please join me in welcome. Oh, there they are. You can come up right behind me. There you go.
Thanks, Jason.
Hey, so welcome, guys. So Anil, can you start off and tell me why is this important to the OCP community?
Sure. Together, Microsoft and Intel, we're pleased to inform everybody here that we're working with partners like Facebook in order to open up and collaborate on an open platform root of trust capability. So our fundamental intent is to take the 1.0 version of the spec, which has been working on for some time, and get that into implementation. Then start working on the 2.0 spec that we want to invite everybody in the audience and all the community members to work with us and collaborate on. The 2.0 spec is going to be built on the NIST standard specifications. We're going to extend the NIST standard specifications. We're also going to add some of the innovations that were there in the Cerberus 1.0 specification and include some of the innovations that we've done with the Intel PFR, Platform Firmware Resiliency. The nice thing about what we're going to do is we're going to extend this to include things like in-silicon root of trust, secure key management, secure key storage, and advanced management capability for the platform root of trust capabilities. So some of the things that we're doing here is definitely open. So we're going to include standardized specifications, standardized API, open source RTL, and even open firmware and any type of software that we need to incorporate. So excited to be joining with Microsoft and Facebook in order to do this.
Me too. So Kshagra, tell us, how does this build off of Cerberus, and why is this interesting to Microsoft?
Yeah, so I think if you just, that's a great question. If you take a step back, originally we came up with the concept of Cerberus so that there could be a base platform root of trust that will secure the platform stack all the way up. Security, of course, is the foundation of our infrastructure. Now, when we think about where do we take this forward, right? So that's where this new effort is pretty exciting. Because what it allows us to do in the OCP community is to take the starting point with Cerberus v1 and build upon that with innovative ideas from Intel and Facebook and the other parts of the community on how to evolve that specification to a second generation. I think if you look at that picture on the screen, the interesting part there is that the evolution of the spec goes from having a root of trust that is native inside every piece of silicon, right? So that is when we talk about tamper-proof security and the ability to have attestation and confidence that the hardware has not been altered, there is no better place to put that root of trust other than inside the core hardware itself when the silicon is built. So so I'm looking forward to this collaboration via OCP, where we can continue to advance the state of the art in security and do the in-silicon root of trust, which will be beneficial for everybody.
Great. Thank you guys very much.
Thank you, Jason.
Thank you, Jason.
Thank you.
Thanks.
And we really are looking forward to embracing the community and hearing your thoughts about how we can accelerate this project. I don't think there's ever been a more important time to make sure that we as a community are focused on the security of our platforms. But continuing forward and thinking about complete solutions, there's still more that we need to do. And Intel has a history and a long-standing commitment to open. And I wanted to highlight just some of the other projects, because I don't think OCP is just about what we do here in this room. It's a strategy, it's a mindset. It's about a belief fundamentally that we collaborate better together, that we advance faster when things are open. And we've driven a number of projects that I want to make sure, even though they might not be within the OCP organization, are still, I think, important to the OCP community. We're working very focused on isolation and on the security and optimization of infrastructure platforms. For example, our Kata containers are designed to improve security and isolation of containers. Our NEMU effort is a lightweight hypervisor, also designed to be more efficient in terms of how it's deployed. We work very closely in the OpenStack and in the Kubernetes communities to drive workload orchestration and make sure it's efficient, especially as we're looking at the need for AI. How do we do a better job of orchestrating AI workflows into a workload orchestration environment. And how do we optimize for AI? And you can see there's a tremendous amount of effort for us, and we want to make sure that we are leading the community in open AI in general, not just the open frameworks and supporting things such as the Glow community, as I mentioned earlier, but for example, our Open Vino platform, which is designed to be optimal for inference and visual understanding, a whole range of libraries that we're putting to the community. AI is going to be a huge differentiator and hopefully something that benefits the world and the community. And I believe it can only be done if it's based on open platforms. So lots covered in the short 20 minutes that I had up here. I know it was a bit of a flyby. It was almost like this family reunion. We came, we ate meal, and then we took off. But I want to make sure that there's still more meat that you get. I hope that you get a chance to stop by some of these sessions later on today. I had dinner with Brad Burris last night. I know he is super excited to talk to you about the OCP NIC, but whether it's the cloud-optimized platform or some of the AI accelerator stuff, please take note of these sessions. Come visit us. Tell us what we can do to be a best partner and a great collaborator with you here in the community. Thank you very much.